Question 16 is about using your knowledge about resistors in series and parallel and Question 16 is about using knowledge about resistors in series and resistors in parallel and current and voltage and power, and using that knowledge in order to design a car rear window demister, and using that knowledge in order to design a car rear window heater. So the bits that we've got to have, the design brief says that whatever we design has got to have an output of 48 watts and it's got to use a voltage of 12 volts because of course it's for a car battery. So the first part of the question, calculate the current supplied by the power supply. And now this is before we've done any designing. We don't know whether it's going to use series or parallel, but all we know is that it's going to use a 12 volt battery and it's going to give 48 watts of output power. So if you think of the connection, so if you think of the equation that links voltage and power and current, then that's the equation you need to use to find the current that must be going through the battery. When we get to part B, we're considering one of the options, and one of the options is for the 8 elements to be connected in parallel. Well, you've already worked out how much current's got to flow through the battery in total. So you have to think what happens when you connect resistors in parallel with each other. What happens to the total current from the battery when the current reaches 8 routes in parallel? How much current will go through each route? Think about that, you can work out the current in each element. Once you know the current in each element, then you're able to work out what the resistance of each element has to be. Because we know if they're in parallel, they're all connected to the 12 volt battery. So we know there's 12 volts across each one. We know how much current's got to go through each one. So you can calculate the resistance of each one. For part C, we consider the other alternative, which is to have the 8 elements all connected in series. In the first part of part C, it says calculate the current in each element in this series arrangement. Now when it says calculate, there isn't actually a great deal of calculation to do. As long as you've got your wits about you and you know something about series circuits and you know that you've already found how much current is going through the battery, it ought to be a very quick and easy job to work out how much current must be going through every one of the resistors. You've then got to find the resistance of each element. So you know the current through each element. Got to take care with the voltage though. If they were in parallel, the voltage would be 12 volts for each one, but they're not, they're in series. And when you connect things in series, they have to share the voltage. So before you can work out the resistance, you've got to work out what's the voltage across each of the 12. So before you can work out the resistance, you've got to work out what's the voltage across each of the 8 elements. Part D is to state one disadvantage of using the series design compared to the parallel arrangement. And there's one really obvious one that comes to mind that's based on common sense really, sort of GCSE sort of knowledge. And since I'm doing this at Christmas, you can sort of think that the same argument could apply to Christmas tree lights. So part D says that despite the fact that you've found a disadvantage of the series design, the manufacturer does decide to go for the series design. And it says each element is to have a rectangular cross section 0.12mm by 3mm, and the length of each element is to be 0.75 meters. So for the first mark here, you've got to state the unit of resistivity. Well, that's something you should just have learned. And then you've got to calculate the resistivity of the material from which the element must be made. So if we have a look at what the element looks like. each element will be this sort of shape. The cross section is a rectangle, and then it's 0.75 metres long. So if we're going to find the resistivity, we're going to be using this equation, the one that's on the data sheet. And you know the resistance because you calculated it in part C. You know the length because you're told how long each element is. You've got to calculate the area. So the area is 3 millimetres times 0.12 millimetres. So you work out the area of that rectangle that's shaded in there. You've also got to be very careful though, because these distances are given in millimetres. If you're going to use this equation, you've got to put the area in metres squared, so you've got to do some conversion there.